Hello again, this is Dr. D, and today we are going to talk about blood vessels. Alright, in our cardiovascular section, we talked about the heart, we talked about the circulation, systemic circulation, pulmonary circulation. We know that yet. So now let's look at the arteries, veins, and capillaries. Okay? So first and foremost, see, an artery brings the blood to any organ, and the artery is going to break down into smaller vessels. So here's my artery. These smaller vessels are called arterioles. The arterioles are going to break up into tiny vessels, and these are called the capillaries, which are going to supply the tissues with blood. So I'm going to draw the tissues in here. These are just cells, okay? Now from the capillaries, the blood is going to be collected via bigger vessels, and these vessels are going to be called what? Venules. And finally, the blood is going to flow into the veins. You have to know this division. All right. So let's look at the difference between an artery and a vein. First, just look at the walls. Now, what do you notice? That the tunica media of an artery, which is the middle wall, is so thick for an artery, right? So there are three walls. What is that? Three layers. There's the tunica interna, there's tunica media, and tunica externa. The artery has a thicker tunica media than a vein. That's the first difference, right? Second difference, an artery, look at the lumen. Lumen is hole. The hole through which the blood is going to pass. The lumen of an artery is going to be smaller. The lumen of a vein is going to be bigger. Do you see this? What's the third difference? We already talked about that. Artery will carry the blood to the tissues, right? To the tissues. In fact, let me redraw this for you. So if you remember this, the heart, the box drawing, right? And we had drawn the lungs in here, and we had drawn the body in here, yeah? And what did we say? From the body, blood is collected and goes through the vena cava, yeah? So what kind of blood was this? The blood that was carried from the body via the vena cava into the right atrium. This blood was deoxygenated, right? So what we are saying is the veins and the venules will always carry carbon dioxide rich blood. The arteries and arterioles will carry oxygen rich blood. That's the difference number 3. You have to know these differences. Except for one exception. What was this? Right ventricle, right? Right ventricle carry the blood to the lungs via what? Pulmonary what? Artery. I'm just going to write PA in here. And keep this in mind that this entire side of the heart is carrying deoxygenated blood. So when you say this artery always carries oxygen rich blood and veins carry carbon dioxide rich blood, make sure you say except for pulmonary artery that carries carbon dioxide rich blood from the right ventricle into the lungs. All right. And pulmonary vein from the lungs, which carries now oxygen rich blood, because in the lungs what happens? Carbon dioxide is given off, oxygen is taken in. So the blood leaving the lungs is rich in oxygen, going into the left atrium, excuse me. So here, this pulmonary vein is going to carry what? Oxygen rich blood. So this is the exception. All right. Number 4. What is number 4? The veins are going to carry the blood to the heart, and the arteries are going to carry the blood away from the heart. That's number 4 difference. Number 5, the blood pressure in an artery is always going to be higher. Let's see here. So here, this is the left ventricle, and from the left ventricle the aorta comes to the body, right? So obviously the blood is going to flow at a very high pressure. So the blood is at a higher pressure, high pressure, and we will see this later on in artery. Low pressure in a vein. The blood is flowing up into the right atrium via the vena cava. What's vena cava? Vena cava is just a big vein, and aorta is nothing but a big artery. So which one flows at a higher pressure? When you suppose here's a hill, okay, and water is flowing down. So obviously the water that's flowing down a mountainside will be under high pressure, right? Yes or no? If I had to pump this water up, will it be under high pressure or low pressure? Low pressure. So that's what I'm trying to explain to you, that blood is under high pressure in an artery. Blood is under low pressure in a vein. That was the fifth difference. Sixth difference is because the veins have valves. All right, we'll see this in the next slide too. So the veins have valves. Valves are missing in arteries. Okay, so these are the basic 6 differences that you should keep in mind. All right, let's move on. Here are the differences. You can read that up. Capillaries. Now, without going into too much of detail, capillaries are where the real work gets done. Okay, that's where exchange takes place. The capillaries, they have spaces or slits, as you can see, and these slits will allow the blood to escape. Remember the first chapter we did in 202, the chapter on blood, we said that what happens is always, except for RBC and large proteins, the rest of the blood can escape out from the capillaries, especially if there's a cell which is endangered, which cell is being attacked. So if a cell is being attacked, the granular and agranular cells can escape, come out, and will attack the pathogen. Yes. And this diapedesis, this escape, is possible because of the slits. So the capillaries typically have a single layer of cells. They're very, very tiny, very, very small, and they vary in size. All right. So you can read up the capillary network, but one thing that I definitely need to point out is precapillary sphincter. And what happens is that not all the blood goes through all the capillaries at the same time. For example, if you have eaten, definitely you will need more blood going into your digestive tracts for help for digestion and absorption. So therefore what happens is these sphincters are open, so more and more blood flow will go into the digestive system. But say for example, when you have finished digestion, or when you are in class and you really want to think, or you really want to pay attention, then more and more blood will be going into your brain. Why? Because of course your brain cells are being used, right? So at that time those sphincters will open up. So in this way it will restrict or control the entry and the passage of blood. So this will allow shunting of blood where it is needed. All right. So these are the venous valves that I talked about, that the valves have veins, and this will allow or prevent backflow of blood. So often people who end up standing for a long time, you will see that they will end up with these varicose veins, and you can see that it will lead to, here you go. So varicose veins, they will lead to what? This is because of the pooling of the blood, and the valves will become distorted. So it's either you see it as varicose veins. Those of you who have jobs standing up for a long period of time, please be careful. Hemorrhoids is also again stretching or distension of the veins because of blood pooling. And varicocele. Varicocele happens in males, where what happens is that there will be pooling of blood in the scrotal sacs and leads to infertility. Blood distribution, important slide. Where is blood found the most? In the venous system. Now I will not be asking you the number. All right, so at no point will I say, okay, what's the percentage of blood distribution in the venous system? Question will be like, true and false, or multiple choice. So here, which one has the highest or the most distribution of the blood, or where is blood found the most in? Venous, pulmonary, heart, systemic, or systemic capillaries. So obviously 64% most in the veins, and least amount will be in the heart or in the systemic capillaries. Do you see this? So and you should understand why. Why should there be more amount of blood in the veins? Now don't forget, with the veins, the blood is flowing back. So the blood is going to be under low pressure. It's going to take time for it to return the blood to the heart, okay? The going down through the arteries fast. That's going to be really fast. And then pressure. So here, what is the blood pressure highest at? So the blood pressure, you are noticing, the blood pressure is highest in the arterial side. Notice out here. Once again, I'm not going to be asking you the amount, all right? But you should at least know that the pressure at the artery side is going to be much higher than in the venular side. Venous side of the blood, notice out here what it says, 8. And what does it say out here? 11. So blood is under higher pressure as it is coming into the capillaries, and lower pressure as it leaves the capillaries, all right? All right, so therefore the resistance of blood flow is because of vascular resistance, blood viscosity, and turbulence. I will show you this with this slide. I'll go straight into this slide, blood pressure. So with blood pressure, you are dealing with certain factors: volume, heart rate, stroke volume. Now, heart rate and stroke volume we talked about in the last presentation. So please read that up. Blood volume is, if there's more retention of fluids, the blood pressure will increase. Now, what about blood viscosity? If there's increase in cell density, if there's polycythemia, then there will be a higher blood pressure. If there's peripheral resistance, means there's friction between blood and vessels, right? And why is that? If there's contraction of arterioles, or if there's plaque in the arterioles, there will be more peripheral resistance. All these factors are going to increase blood pressure. Now, this information obviously will be very important, especially when we're talking about blood pressure, which is a bane, a problem in the modern day world. Now, the next slide, of course, is where is the pressure the highest? Pressure is highest in the aorta and the least in the vena cava. Do you see this? That's why when you, and what's the normal blood pressure? Of course, you should be knowing this. Now, this chart, the book says 120/80, not true. Now, the correct or the standard blood pressure, normal blood pressure, is 119/79. This 119 is the systolic pressure of what? Systolic pressure, all right? And the 79 is the diastolic pressure. Obviously, we are talking about the ventricle. So here is the blood pressure. Okay, so you have to know this. And how do we measure the blood pressure? We measure blood pressure by an instrument, and you obviously have seen this. It's called the sphygmomanometer. All right. So the working of this, of course, as nurses, you'll have to know this, and you can read this up. I'm not going to be asking you about the working of a sphygmomanometer, but you should know this instrument, name of this instrument. All right. I'm just checking what I missed. All right, so here, with this being said, I am going to stop here. These are the baroreceptor reflexes, and we can talk about it more in the next slide as I'm running out of time. And I thank you for your patience. If there are questions or concerns, please stop by my office or contact me. Thank you for listening to me. Have a great day.